Hello Kotlin enthusiasts, in today's course we are delving into the world of functional operations on collections. These operations empower us to write concise and expressive code, transforming the way we work with data in Kotlin. We get ready to explore the beauty of functional programming in collections. What I'm going to do is create a file, click on that file, and let's go with functional operations. Now once that is done, I'm going to say fun main. Okay. Now, so functional operations on collections are a set of powerful tools in Kotlin that allow us to perform operations like mapping, filtering, and reducing on collections in a functional and concise manner. Let's dive into the details. Let's do a map operation. Let's create a function, suppose map operation. Okay, so what's the error over here? Let's create a variable. I'm gonna say list of and 5. Now once that is done, I'm gonna say, suppose I need to square all the numbers that are present in this list. So how to do it? I'm gonna say val squared numbers. I'm gonna say numbers dot map. I'm gonna say it into it. Okay, and then I'm gonna print it. I'm gonna say println original numbers, and then again println. I'm gonna say square numbers. Done. I don't know what's the issue with this. Copy this thing, paste it over here. Fun main, I don't know what's the problem. Okay, let's run the app and let's see what happens. I don't see any issue. Let's see. So in this example, the map operation is used to square each element in the list. The concise syntax of Kotlin allows us to transform the entire collection effortlessly. Okay. Conflicts, overloads. Okay. So map operations, let's use S over here. Okay. So an overload was occurring actually. That means a by default function was available already in the Kotlin library, which was causing this issue. Now it's resolved. So you will see the output in squared numbers as all the outputs will be squared. Okay, here we go. The squared numbers. Okay, so this is how you could basically directly do all the things, all the operations. Now let's take a second example in which filter operations we are going to use. We are going to do filter operations. So I'm going to say filter operations. I'm going to say val numbers is equals to list of 1 comma 2 comma 3 comma 4 5. Then I'm going to say, suppose I want to get all the even numbers in the list, so I'm going to say even numbers is equals to numbers dot filter. I'm going to say it modulo sign 2 is equals to 0. That means okay, sorry, I need to use curly braces over here. So basically I will iterate through all the numbers and I will check whether 2 by dividing it by 2 I'm getting the remainder as 0 or not. If I'm getting, if this value satisfies and gives the result as true, then I will assign the value to the event. And then I'm gonna say original numbers then I'm gonna say println even numbers just copy this, paste it over here, try to run it. The filter operation helps us easily select elements from the collection that satisfies a given condition. Here it filters out only the even numbers from the list. Here we go. Okay, great. Let's take one more example in which we are gonna go with the reduce operation. So I'm gonna say fun reduce operations. Then I'm gonna say val numbers is equals to list of 1 2 3. Okay, let's do it again. Val numbers list of 1 2 3 4 5. Then I'm gonna say, suppose I need to get the sum of all these numbers, so 1 plus 2 plus 3 plus 4 plus 5. What is the sum of all the numbers I need to get? So how I'm gonna say, I'm gonna say val sum is equals to numbers dot reduce I'm gonna say ACC. So ACC is basically stands for accumulator. Okay, so I'm gonna tell you how this thing works. So I'm gonna say ACC, I'm gonna say number, make sure it's not S over there, number, I'm gonna say ACC plus number, make sure curly braces are there again. Okay, then I'm gonna say print ln original numbers println sum. Okay, so how this will work is, initially the accumulator value would be 0, okay, and the number would be 1. So 1 will be here, and accumulator value is 0, and number value is 1. So 0 plus 1, that is 1. It will assign the value to number, and that will be assigned to the accumulator. Okay. Now the compiler will come to the second element. In the second iteration, the ACC value is 1, and the number is 2 basically. So 1 plus 2, that is 3, and the compiler will copy that value to the accumulator. Now the accumulator value is 3. Now in the third iteration, the accumulator value is 3 and the number is 3, right? So the in the third iteration, after the third iteration, the accumulator value is 3 Similarly, it will work according to it. Okay, just copy this reduce operations in the main function and try to run the program. The reduce operations is perfect for aggregating values. It combines elements in the collection using a specified operation. In this example, it calculates the sum of all the numbers in the list. Here we go, 15. And there you have it. Functional operations on collections in Kotlin provide an elegant and expressive way to manipulate data. By mastering these operations, you can write code that is not only concise but also more readable and maintainable. So go ahead, explore the possibilities and enhance your Kotlin programming skills with functional programming on collections. Happy coding, meet you in the next lecture. Thank you.